So 9608 P42 MG21. So let us start. An ordered binary tree. An ordered binary tree stores the following data: horse, donkey, and kangaroo, and cat, and elephant. Now, ordered binary tree means that every new node, when it is being added, it is being added as per the rules of ascending order in the binary tree. That whatever the data that you have to compare it with the node. If the data is less, you will go left. If the data is greater, you will go right. And that is how you will keep doing that until you reach to a point where there is no node. And then you'll create a node and put the data there. Okay, so that is ordered. You might have questions in 9618 where you have unordered tree, where any node can be put anywhere without any consideration of the order. Okay, so let us start. An ordered binary tree stores the following data. Identify the data in the root node of the binary tree. So this is horse. This is the root node. So this is horse. Identify the data in one leaf node. What are leaf nodes? A node with no child node. So this is a leaf node. This is a leaf node, and this is a leaf node. So it might be cat, elephant, or kangaroo, any. Cat, and cat, elephant, and kangaroo. Complete the binary tree by adding the following data in the order given. So now the first thing is fish. So fish is less than, F is less than H. If you do remember from P2, we don't have to compare the whole string, just the first character of it would be suffice to compare it. So we will be comparing only the first character. If the two match, even if they are uppercase and lowercase, then we have an idea that uppercase ASCIIs are before lowercase ASCII. So that is quite up to it. Now, if the two are same, then we will match it with the next character and then next character, and that is how we go further. So F comes before H, then after D, and after E. So fish will go this side. Then we have this. So this is I. So I will be greater than H, I, J, K, less than kangaroo. Like one. Then we have got this. So R is greater than H and greater than K. So we have here, this is rabbit. Then we have got jaguar. So jaguar J is greater than H, less than K, greater than I. So this will be on the right side. Okay, right side, jaguar on the right side of iguana. Now, explain how an algorithm will search binary tree to find the elephant. So yeah, so we have to explain it in for just 2 marks. Explain how algorithm will search the binary tree to find elephant. So first we compare elephant to root node data horse. E is greater than, E is less than. E is less than H. So move left subtree. Then we come across what? D. E is greater than D, so move right subtree. ठीक है? Now we reached elephant. E is equal to E. Compare elephant is found. That is how the आपको, you don't have to actually tell that what is the algorithm. You have to tell that how the comparison occurs at every node and then how you move towards left and right and all. Now, question number 2. Question number 2 says a company stores booking in random file. All right. For each booking, the booking ID. For each booking ID, customer ID, item ID, and quantity are stored. These 4 values are all integers. Write the pseudocode record declaration. So this is record declaration. Record declaration is basically UDT. All right. So let us start. So this will be type. The name of the type would be booking. You can write record as well. So type is better. Recently, they have been using just word type. So declare booking ID as integer. Declare, ये हम ना एक साथ भी कर सकते हैं. Customer ID as integer. Declare item ID as integer. Declare quantity as integer and type. All right, and type. So this is the pseudocode for type booking, record type. Each booking ID is value between 100,000 and 999,999 inclusive. Pay attention to word inclusive, okay? The hash value is calculated by dividing the booking ID and adding 3 to the remainder. The function hash takes the booking ID as parameter, calculates and return the hash value. So we are going to actually write pseudocode for the function hash. So function hash, it receives booking ID. Well, we don't need to write by val and all, but just to remind you, booking ID as integer and returns integer. what it does, the hash value is calculated by dividing the booking ID by 100,000. So we need to have a variable here, declare hash key as integer, dividing booking ID by 100,000 and adding 3 to the remainder. So hash key initialized, then hash key is equal to booking ID. Remainder में we have to add 3. So mod 100,000 plus 3. Okay, and then return hash key and function. Now let me tell you that you don't have to write such big code. You can write it as small as this. Function hash booking ID as integer returns integer, and then inside just write return booking ID mod 100,000 plus 3 and function. Okay, do you get it? Compare these two. You get 2 marks for this, 2 marks for this as well. Obviously, function header and function footer will remain the same. Instead of having a new variable, initializing it, then calculating value to that new variable and returning that, you can all do that in just one line. Divide the booking ID by 100,000 and add 3 to the mod and return it. So you can write as short code as given. Calculate the hash key for each booking ID in the table. So let's do that. 5 0 1 2 3 4 5 100,000. So 100,000. Well, I do this directly. The answer would be 12348. You would have, after doing all this, you would have this answer, and then you will add 3 to it, and then you will have this 12348. Similarly, for this 82123550, the answer would be 12350. Then you add 3 to it, 12353. That will be your answer. The function is store booking. The function store booking takes a record as a parameter and stores it in a random file, the booking.dat. Random file, the booking.dat. All right. Takes a record as parameter and stores it in the random file the booking.dat. The function uses hash to calculate the hash value for that record. The record is only stored if the value at the hash value is null. All right. False is returned if there is already a record that look in that location, and true otherwise. So basically what is happening, the system is receiving a booking record as parameter, sending it to hash, dot booking ID, and if we have any particular value already existing at that particular location, in that case we will be returning false. Okay, so hash value, then we go to that particular location and then we check and see if that location does have any data in it. Okay, now the function store booking function store booking takes a record, call it booking record, as what was the name? Booking, of type booking. Takes a parameter and stores it in a random file. The function uses hash to calculate the hash value for that record. The record is only stored if the value at the hash value is null. False is returned. Returns false. Returns false means it is Boolean. Okay. Now we have to calculate record location. We have to calculate record location. We have declared it and initialized it. Then hold on for a moment. Then we have to call the hash function. And send booking record dot booking ID to it. Now it will return a hash. Now let's keep that hash first. Let's open the file. What is the name of file? The bookings.dat. for random. If you do remember, random files, once they are opened, they can be written into, they can be read from, they can be updated, they can be appended, all can be done with just one opening, and that is for random. Okay. Now we have to seek to the record location first. Seek the bookings.dat, comma, record location. We reached out to that record location, and then we have to read the record. Okay, now I have to declare my record as booking. Now get record. The booking stat into what? My record. Now we have to check if from that particular location that was fetched from the file, if it does have some data to it, it means that we have to return false. And if it is no data, means the location that we have seeked and then we read the record from, if that location does not have any data, means it is null, then in that case we will update the file and return true. Okay, so if my rack is not equal to null, okay, if it is not equal to null, then we will put record in the file and we will put booking record there. That we have received as a parameter. Otherwise, then first let's close the file. Okay, there is a question. Sir, अगर record खाली है तब नहीं रखेंगे? Yes. मतलब if record is null, yes. Yes, exactly. नहीं, जब खाली है तो रखेंगे. अगर खाली नहीं है यानी कि उस पर पहले से record रखा हुआ है तो हम return false करेंगे. Okay, and then return true. Else return false. Now we have to close the file first. All right. So Yes, you are correct, Bilal. This must be equal. Thank you. Yes, yes, yes. I made a mistake. I have corrected it. So this is function store booking. It receives a UDT booking record and it returns Boolean. Then it has a record location that is calculated using the hash function. We are supposed to save the record at this particular record location. Then we open the file and go to that particular record location that was calculated by the hash function. We actually read the record there in my record, which is of type booking UDT. And then we check if the record is null, means there is nothing saved there. Then we put record that we have received as parameter there, close the file and return true. And if it was not null, as in it has data already in it saved at that particular location, then we return false. That's it. So this was 7 marks question. Explain how exception handling can be used. Exception handling can be used when reading from a file. All right, we will use catch. You remember catch? It was catch. Exception handling. So if you do remember, try, catch, and try, and finally. So whatever the code that you write here might have some runtime error in it. Okay. So if that error occurs, in that case, system does not basically crashes. The program continues and it goes to the code that you write in catch. This finally works anyway.